warahmatullahi wabarakatuh. Hello guys, how are you today? I hope all of you are healthy and happy. Let me introduce myself. My name is Nurfitri Oktalina Darmayanti. You can call me Ode. I'm from Class A, Mathematics Education 2018 in UIN Antasari, Banjarmasin. Previously, I want to tell you that this video was made to fulfill a final assignment in English for mathematics. Today, I will explain about counting and writing number, ordering number, rounding, prime, and composite number. Before you watch the video, don't forget to like, comment, and subscribe. Happy watching, guys!
Integer operation. Addition of integer. Example 1. To add two positive integer 8 plus 3 and plus 2. For that, first shift 2 units to the right of number 0, then shift 3 units to the right of number 2. As a result, we shift the whole 5 units from 0. Example 2. To add positive integer and negative integer 8 minus 3 and plus 2. First, shift 2 units to the right from 0, then shift 3 units to the left. Overall, we shift 1 unit to the left from 0, open bracket, minus 1, close bracket. Note, when we add two integers, the symbol attached to the numbers do not change. Example 3, 8, open bracket, plus 4, close bracket, equals 3, 8, 4, equals 7. 5, 8, open bracket, minus 3, close bracket, equals 5, minus 3, equals 2. Subtract integer. Example 1. To subtract positive integer. Subtract plus 2 from plus 3. First, shift 3 units to the right from 0, then shift 2 units to the left. As a result, we shift 1 unit to the right from 0. Note, when we subtract an integer with another whole number, we change the sign and then add the two numbers together. Example 3 minus open bracket plus 5 close bracket equals 3 minus 5 equals minus 2. Open bracket negative 4 close bracket minus open bracket negative 6 close bracket equals open bracket negative 4 close bracket 8, 6 equals 2. Multiplication of whole number. Example, to multiply two integers with the same sign or symbol. When multiplying two whole numbers with the same symbol, we are using the absolute value and the result is a positive symbol. Positive times positive equal positive, while negative times negative equal positive. Example, positive 4 times positive 5 equals 2, or minus 2 times minus 5 equals 10. Integer division. Consider the following example. Atta plans to give 4 dolls to his 4 friends as thanks. He has 12 dolls. If distributed evenly, each friend gets 3 dolls. This is a sharing process. From this we know that 12 divided by 4 equals 3. Next, ordering number. Ordering numbers mean arrangement of numbers either from small to big or from big to small. When we arrange the numbers in an increasing order, it is known as ascending order. And when the words are arranged in a decreasing order, and then they are known as descending order. For ascending, check the smallest number from the given list and place it first, and put the number according to the increasing order. For descending, check the biggest number from the given list and place it first and put the numbers according to the decreasing order. Let us take the following example and arrange them in the given order. Let us take the following examples and arrange them in the given order. 1, 12, 14, 45, 5, 34, 79, 10. Ascending order 5, 10, 12, 14, 34, 45, and 79. Descending order 79, 45, 34, 14, 12, and 5. And number 2, 1, 1111, 11, 111. Ascending order 1, 11, 111, 1111. Descending order 1111, 111, 11, and 1. And number 3, 89, 98, 12, 21, 34, and 43. Ascending order 12, 21, 34, 43, 89, 98. Descending order 98, 89, 43, 34, 21, and 12. Next, rounding. Rounding methods. There are various rounding definitions that can be used to round a number. The calculator defaults to rounding to the nearest integer, but settings can be challenged to use other rounding modes and level of precision. All the rounding modes the calculator is capable are described below. Round half up. This rounding method is one of the more common rounding methods used. It means rounding values that are halfway between the chosen rounding precision up. For example, when rounding to the ones place, 5.50 equals 6. 5.51 equals 6. 5.49 equals 5. When the value being rounded is negative, the definition is somewhat ambiguous. Some round negative 5.5 to negative 5, some round to negative 6. We agree here the up can be thought of as rounding values that are halfway toward the bigger or more positive value. For example, when rounding to the ones place, negative 5.50 equals negative 5. Negative 5.51 equals negative 6. Negative 5.49 equals negative 5. Round half down. Rounding half down is similar to rounding half up, except that it means rounding values that are halfway between the chosen rounding precision down rather than up. For example, when rounding to the ones place, 5.50 equals 5, 5.51 equals 6, 5.49 equals 5. In the case of negative numbers, same as rounding half up, the definition is ambiguous. We agree here rounding half down can be thought of as rounding values that are halfway toward the smaller or more negative value. For example, when rounding to the ones place, negative 5.50 equals negative 6. Negative 5.51 equals negative 6. Negative 5.49 negative 5. Round up ceiling. Rounding up sometimes referred to as taking the ceiling of a number means rounding up toward the nearest integer. For example, when rounding to the ones place, any non-integer value will be rounded up to the next high integer as shown below. 5.01 equals 6 ln. The case of negative numbers, rounding up means rounding a non-integer negative number to its next closest more positive integer. For example, negative 5.01 equals negative 5. Negative 5.50 equals negative 5. Negative 5.99 equals negative 5. Round down floor. Rounding down, sometimes referred to as taking the floor of a number, means rounding down toward the nearest integer. For example, when rounding to the ones place, any non-integer will be rounded down to the next lowest integer as shown below. 5.99 equals 5 ln. The case of negative numbers, rounding down means rounding a non-integer negative number to its next nearest more negative integer. For example, negative 5.01 equals negative 6. Negative 5.50 equals negative 6. Negative 5.99 equals negative 6. Round half to even. Rounding half to even can be used as a tie-breaking rule since it does not have any bias based on positive or negative numbers, or rounding toward or away from zero, as some of the other rounding methods do. For this method, half values are rounded to the nearest even integer. For example, 5.5 equals 6, 6.5 equals 6, negative 7.5 equals negative 8, 8.5 equals 8. Rounding half to odd. Rounding half to odd is similar to rounding half to even or above, and can be used as a tie-breaking rule. For this method, half values are rounded to the nearest odd integer. For example, 5.5 equals 5, 6.5 equals 7, minus 7.5 equals minus 7, minus 8.5 equals minus 9. Round half away from zero. Rounding half away from zero can be used as a tie-breaking rule and means exactly as the phrase describes, rounding half values away from zero. It has no biases toward positive or negative numbers, but does have a bias away from zero. Another way to think about this rounding method is to round a half value toward the next integer closer to positive or negative infinity based on whether the value is positive or negative, respectively. For example, 5.5 equals 6, negative 5.5 equals negative 6. Round half towards zero. Rounding half towards zero is similar to rounding half away from zero, except that it's round in the opposite direction. It has no bias toward positive or negative numbers, but does have a bias towards zero. The method means that half value will be rounded toward the next integer that is closer to zero than it is to positive or negative infinity. For example, 5.5 equals 5, negative 5.5 equals negative 5. Next, prime numbers. Definition of prime numbers. A natural number which has exactly two factors, 1 and the number itself, is a prime number. In simple words, if a number is only divisible by 1 and itself, then it is a prime number. Every prime number is an odd number except number 2. For example, 2, 3, 5, 7, 11, 19, 37, 41, 313, 241, and etc. 2 equals 1 times 2, 3 equals 1 times 3, 5 equals 1 times 5, and so on. All the above mentioned numbers have exactly 2 factors, 1 and the number itself is the R prime number. And the last, composite numbers. Definition of composite numbers. Every non-prime number is a composite number. Composite numbers are those natural numbers which have more than 2 factors. Such numbers are divisible by other numbers as well. For example, 4, 6, 8, 10, 12, 14, 500, 6,000, etc. These numbers can be written as 4 equals 1 times 4, 4 equals 2 times 2, 6 equals 1 times 6, 6 equals 2 times 3, 8 equals 1 times 8, 8 equals 2 times 4, 10 equals 1 times 10, 10 equals 2 times 5, 12 equals 1 times 12, 12 equals 2 times 6, 12 equals 3 times 4, and so on. Thus, all the above mentioned numbers have more than 2 factors other than 1 and the number itself, hence they are composite numbers. Some facts about prime numbers and composite numbers are: 1 is neither a prime nor a composite number. The only even number which is a prime is 2. It is the smallest prime number. Except 2, all other prime numbers are odd numbers.
Thank you for watching this video. I hope you like this video and I hope this video is useful. I apologize if there are still errors in the pronunciation. See you! Assalamualaikum warahmatullahi wabarakatuh.